Hi, welcome to this on Maths prediction for the OCR GCSE Maths Higher Tier Paper 3 2018. Enjoy! Hiya, okay, so I hope Paper 1 and 2 went alright. We've now removed the Paper 1 and 2 topics to get you a Paper 3 prediction. Like I've said in the previous videos, please use this in amongst all your other revision. There's plenty of topic busters on the site which cover all the GCSE topics, not just the ones in this prediction. The downside of a prediction is it can only be the amount of marks in the paper. There are plenty of topics that could come up that still haven't, and also the exam boards are notorious in repeating some of the previous topics. So use this as a starting point, or use this as a bit of a revision break, a revision check, but please also do the standard revision as you would normally, and see this just as a revision tool. Like always, you can do this online on maths.com. Also, if the servers get busy, which they normally do probably the day before the exam, then please use our backup site, which will be in the description. I hope you enjoy this video, and if you like it, please click like. If you really like it and want to see more from us, click subscribe. Thank you very much. Okay, for this question, we're asked to find the cost of the toffees and the fudges. Now, if we imagine that we had 2 toffees and 3 fudges, how would you work this out? Well, the cost would be 2 times 50p, and then we would add 3 times 70p. The problem is that 2 and 3 I've just made up, so that's not going to be the answer to this question. What it says though is that it wants toffees to be called T and fudges, the amount of fudges, to be called F. So instead of 2 toffees we have T toffees, and instead of 3 fudges we have F fudges. And in algebra, we always put the number before the letter and we don't show the time sign. So it's 50t plus 70f. Now be careful, it does want the cost in pence, but sometimes it wants it in pounds. So if it wants it in pounds, it'd be 0.5t plus 0.7f. So the answer is C equals 50t plus 70f. And that can be either way around. With best value questions, which this is one of, there's normally multiple ways of doing it. Either you get the price per item, or you get how much of the item you get for 1 pence, or you get them to so that they're the same amount of items and then you compare the prices. Now this one asks for the price per tissue, so that's the way we've got to answer this question. So we're going to have tissues on the left hand side and price, and I'm going to do it in pence because it's normally a lot easier to work out when it's in pence. I'm just going to draw a line down the side. So we're going to start off with the box of 24, and it costs 802 pence. Now to get 1 tissue, I'm going to divide both sides by 24. So if I divide both sides by 24, I get 1 tissue. So I do 802 divided by 24, and I get 33.416 recurring. Okay, let's try the next one. So that's 1 done. In fact, if I draw a line, then I can show that I've done that. Okay, so the next one is 20 tissues, and that costs 689 pence. So this time I'm going to divide both sides by 20, so I know how much 1 tissue costs. So 689 divided by 20 on the calculator, and I get 34.45 pence. Okay, and the last one, let's draw our line. So the last one's 15 tissues, and it costs 538 pence. So this time I'm going to divide both sides by 15 to work out 1 tissue. Okay, so 538 divided by 15, and this time I get 35.86 recurring. Okay, so first of all, let's get the price in. So it says rounded to 2 decimal places. Okay, so this first one is 33.42, because that one moves up. The 20 tissue box is 34.45, and the last one is 35.87, because that 6 would round up. So which one is the best value? Well, if you have a look at the 24 tissue box, it's only costing 33 pence, just over 33 pence, whilst the 20 tissue box costs over 34 pence, and the 15 tissue box costs over 35 pence. Well, which one would you rather buy? Well, I'd rather buy the one that the tissues cost the least. So the best value is the 24 soft tissues. Now, in your answer, make sure that you write exactly the same as in the question, so that it's absolutely clear which one that you think is the best value. Now, if you worked the other way, if the question didn't specify how to do it, and you were working out the amount of tissues you get per penny, then obviously it works the other way. You want the biggest number because you want the maximum amount of tissues per penny. So just be a little bit careful of that. At first glance, this seems like a really easy question. It seems like the answer will just be 80. But we've got to understand the way that bearings are written out. It says work out the bearing of A from B. It means that we are at B and we're trying to find where A is in relation to B. So the actual question is asking you for this angle here. Now don't forget, bearings are the angle going clockwise from north. So not so easy. The first step of doing this, and there are different ways of doing this, is just draw a line. In fact, I'm going to use my straight line one. Just draw a line straight down at B. If I can get it right, there we go. Now, north lines are always going to be parallel, and we can use that to work out this angle here. This angle here will be the same as this angle here because they're Z angles or alternate angles. So that's also going to be 80. We know this one is a straight line, so we know this is going to be 180 degrees. So all we need to do to work out the bearing is do 180 plus 80. And when you add them together, you get 260. So the bearing is going to be 260. Now there are other ways of doing it. You could have worked out this angle, because this angle and the 80 degrees over here are co-interior, interior, or allied angles, whichever one you want to call them. So they will add up to 180. So we know that one's going to be 100. And then what we could have done is 360 take away 100, because it's the full circle is going to be 360 and we don't want that 100 one. You'd also get 260. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Oh, always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what one part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the two together, it's 102. So there are 102 sweets altogether. Okay, factorize means put it into brackets. So looking at the first one, there's a t I can divide out of both of them. So I put t on the outside of the bracket, but there's no number because 7 and 5 don't have anything that goes into both of them. So I think, what do I times t by to get to 7t squared? Well, it's going to be 7t. And what do I times t by to get to 5t? Well, it's just going to be 5. You can check your answer by expanding the bracket to check it makes 7t squared plus 5t, which it does. Next one, w is only in the first term, so I can't divide out the w, but there's a number I can divide out of both of those. Now, I could pick 2, but actually 4 is a better number because it says factorize fully, which means I need to take out or divide out the 4 rather than just the 2. So 4 on the outside. What do I times 4 by to get to 12w? Well, 3w. And what do I times 4 by to get to minus 8? It's going to be minus 2. And again, I can expand that to check it. Right, the last one, there's a number and a letter. So I'm thinking the number of 16 and 24 would be 8, and the letter would be A. Okay, so there's two things that we're dividing out this time. So I'm going to have 8a on the outside. So I figure out, what do I times 8 by to get to 24? Well, that's 3. And what do I times a by to get to a squared? Well, that's going to be a. What do I times 8 by to get to 16? 2. And what do I times 2 by to get to 16a? So it's just going to leave it because the a is on the outside of the bracket. So a to a times 2 is 16a, so I don't need an a there. So this question looks quite complicated at first, but actually there are two very simple-ish ways of doing it. We've got two decagons, and so that means they are 10-sided. And you can just count the sides if you want, but if it says it's a decagon, I trust it, it's a decagon. Now what we can do is we could work out the interior angles of the decagons. Well, they'll be the same, so I can just work out one and then double it, and then take that away from 360 to work out A. And that's absolutely fine, that'll get you the right answer. A quicker way maybe, and especially on the non-calculator paper, but it works on both papers, is to draw a line up here and realise that you've got two exterior angles there. And the beauty of exterior angles for polygons is they always add up to 360. So to work out the exterior angle, always write down what you're working out. All you need to do is 360 divided by the number of sides the regular polygon has, and they have to be regular, otherwise you can't just divide them because we're assuming they're the same. So that's 36. So if that one's 36 degrees there, and that one's 36 degrees there, then all you need to do is 36 times 2. Well, 6 times 2 is 12, 30 times 2 is 6, so that's going to be 72. So let's show the examiner that. 36 times 2 equals 72 degrees. This question doesn't ask you to show the reasons for your working out, however most of the questions will, so let's try and make sure we write down some reasons as we go. The first one I'd go for is this one here, which I'm going to call A. Now I know that A is 180 take away 115, so 180 take away 100 is 80, take away 15 is 65 degrees, and the reason is it's angles on straight line. And if I know A, I know that B as well. So B is going to equal 65 degrees as well, because it's an isosceles triangle. All the bottom angles in an isosceles triangle equal, assuming that the isosceles triangle has the two same sides on the left and right. Obviously if it's rotated it's not the bottom two angles, but it's always going to be these two angles here. Okay, so B is 65. Now I can go straight to X, because these are parallel lines, x and b create a z angle, and we need to figure out what the z angle is called, but we're going to say x is 65, it's the same as b. Now, corresponding is the f1, interior or co-interior or allied angles are the c1s, so the one we've got left is alternate. They're alternate angles, they're z angles. So the answer I can write is 65 degrees. The important thing to remember with an estimate question is that you don't get any marks for getting the exact answer. So even if this does come up on a calculator paper, then you won't get any marks for getting the right answer. It wants you to estimate. Normally, that means to round everything to one significant figure. Now there are some exceptions to that. Square roots are an obvious one. If you've got root 82, you won't make that, I should put squiggle lines, you won't make that root 80, you'd make that root 81, because then you'd be able to say, well, that's roughly 9. Anyway, there are some small other exceptions. So let's go through this and let's convert these all to one significant figure. And if I draw some lines in, then that might help me. The line for the first one will be between the 7 and the 3, so that will just be 7. For the next one, the line will be after the 1, so that would be 200. Ooh, switch that back. Get all in the same colour, so that would be 200. Now this is where some people make mistakes. They think that that will round to 0, but significant figures ignore any zeros. It's the first non-zero digit you start counting. So the line will go after the 4. So that will round to 0.5. Okay, now we can times the tops together, or times the two numbers at the top together. So 7 times 2 is 14, with 2 zeros, over a half. And all we can do here is just times the top and bottom by 2. So I can times 14 by 2 to get 28. So 1400 times 2 is 2800. And the bottom times 2, well, that's just 1. So the answer is just going to be 2800 or 2800. Now the point of estimation is you should be able to do it in your head. You have to write down the working out still, but the point of estimation in real life is when you don't have a calculator. So if you're finding something that you've got to do a little grid or something, or work it out a long way, then chances are you haven't estimated enough. Alright, so we're asked to draw a frequency polygon, and the only error you're going to make with this type of question is figuring out what a frequency polygon is. Now, a frequency polygon is where you put little crosses at the points, and the points lie at the group's midpoint. So we've got our first group 0 to 10, so the midpoint will be 5. Next one is 10 to 20, so that's going to be 15. Then 25, then 35, then 45. So the first one's going to be at 5, and it's going to be 6 high. It's going to be like that. Next one's 15, 22. So 22 would be about there. 25, 59. So 59 would be right up here. 25. 35, 15. A little bit lower than that, but that's fine. 45, 4. Now we're only halfway done, and my points aren't exact because the screen I'm using isn't the most precise, but it's good enough. We're only halfway done because what we need to do is join these up with straight lines, so no curves needed. And when you join them up with straight lines, do not ever join up the last 2 points. You're not actually trying to make a polygon, okay? So don't ever, when you join them up, whatever, right? Don't ever draw this line here, okay? That's not a good thing to do, so make sure you don't do that. Okay, and that's it. So midpoints, crosses, and then join them up with straight lines if you're asked for a frequency polygon. Alright, so it says that the town council is saying that over a quarter of the stores get over 30 customers. So we're going to see whether that's right. So over 30 customers would be these two groups here, so 30 to 40 and 40 to 50. So that is 19 altogether. So that's 19 out of, and let's add all the rest up, so 6 plus 22 plus 59 plus 15 plus 4, out of 106. It didn't say it in the question. So it's 19 out of 106, which as a decimal, 19 over 106 be 0.179 to 3 decimal places. So what I would say in the exam is no, because that is 17% or 17.9%. So it's less than 25%. And just write a sentence saying that yes, it's close, but it's not quite at 25%, because even rounding up to the nearest percentage, it's 18%, which is 7% lower than 25%. So just make sure you write all of the numbers in an answer that answers the question. Right, so you'll need a calculator for this question. The different calculators do things slightly different, but by far the most common calculator, and if you haven't got one, I would recommend them, are the Casio calculators. Mine has a shiny solar panel on the top, but you don't need that. The average battery life lasts way longer than you'll ever need the calculator. So the first button I would press, and there's different ways of doing this question, is the button to get the fraction, which on the Casios looks like this. And that will make a fraction appear on your calculator. Now, some of the older ones, the fraction looks a bit weird. It involves like a symbol like this. And actually on the new ones it can, but you need to change the settings if it does that. It should open up, it should look something like this, like a box and then another box, and there should be a cursor blinking in this box. Okay, so we want to fill in this top box first, since it's already flashing. So 76.8 plus 81.9. Okay, and so to shift downwards on the Casio calculators, there's a sort of cursor, like a cursor stick, a direction button thing. It's the big blue button beneath the screen on most of the calculators, and you just push the down to go to the denominator of the fraction. And then we need to fill in this bit here, so 0.19, and then to get the squared button, it's on like that. So you just press that, and it looks exactly as it does in the question on the screen, so you know you've got it right. So you press the equals, and my one comes up with 4396.121884. Now, it might be tempting to try and round that, but it says it wants all the figures, so just put them all in. Now, if your calculator is set to a mode which is going to show even more numbers, then normally six digits after the decimal point is more than enough. They won't require you to go to 100 or 200 decimal places. On this question, that's actually an exact amount. Okay, so write down correct to 2 significant figures. Now, to do 2 significant figures, we start counting at the start of the number. So I'm going to do a red line where you need to start counting. And you just count 1, 2 numbers. So the blue line is where I've stopped counting. Now, all of these numbers here are going to be reset to 0. They're going to go away. Well, not quite. Let's come to that later. Now, this number here, the 9, is what we call a decider number. Now, that number is going to go. That 9 is gone. Okay? But before it goes, we need to see whether that is 5 or more or 4 or less. If it's 5 or more, it pushes that 3 up to a 4. So the answer will be 4, 4, and then you'd think, oh, okay, that's it, rounded, and you'd write that in the answer column. But when I said they disappear, they don't quite disappear. All the numbers above the green line that I've just drawn reset to 0. They turn to 0. Now, if you think about it, if I don't know what would have a decimal place, but if you have a number 4,396.121884 written down, and someone says, "Can you tell me roughly how much that is?" Then if you say the answer of 44, that's not roughly 44. It's nowhere near 44. So the 9 and the 6 will turn to 0. And actually the other numbers do too. But these numbers here are not changing the number at all. These two zeros here will make that 4,400 instead of just 44. The other numbers after decimal point, we might as well get rid of them. So the answer is 4,400. Okay, because we don't need to show these numbers. Now, the reason students make this mistake is they're so used to decimal places. Now, decimal places, you always remove them because they're always after the decimal point. But with significant figures, they need to turn to zeros. Now, this is quite an unusual question because it's asking us to find the mean from a bar line graph. Now, what I would do is I'd first of all just start drawing a table for this information because I'm used to finding the mean from a table, so that's what I'm going to do. And so we've got pets, we've got the frequency, and we'll worry about the last column in a second. So 0 pets, the frequency is 6, 1 pet, the frequency is 10, 2 pets, the frequency is 6, 3 pets, the frequency is 6, and 4 pets, the frequency is 1. Now, to find the mean, you add an fx column, and I always call this, whatever is here, x, and I always call the frequency f, so it's the fx column, and you just times them together. So it's just a way of finding out those 6 that were 0, well, how many is that in total? Well, that's going to be 0. Those 10 that had 1 pet, how many pets is that in total? 10. Those 6 people who had 2 pets, well, how many pets are there in total? Well, 2 times 6, which is 12. There were 6 people with 3 pets, so that's 18 pets altogether. And there was 1 person with 4 pets, so that's 4 altogether. Then what you want to do is you want to add up the fx column, and we do that with a little e symbol, just means sum of. So I'm going to do that on the calculator now. So 0 plus 10 plus 12 plus 18 plus 4, which is 44. You also want to add up the frequency column, so sum of frequency. So it sometimes tells you in the question how many there are, so just double check that. So I'm going to add those together, so that's 29. Now the mean is all of this stuff added together over how many there are. So you kind of want to swap these over. Okay, so it's 44 over, which means divide, 29. So 44 divided by 29. And it comes up with a fraction on the calculator, so just press S to D. And that equals 1.5172 blah blah blah. It asks for 2 decimal places, so to 2 decimal places that is 1.52 because that 7 moves that 1 up. Okay, so in this question we're given recipes for 12 biscuits, and that's going to be important. But we're also told that Fred wants to make 18 biscuits. Complete the new list of ingredients, like the amounts of the ingredients. So I've got to somehow get from 12 to 18 by just timesing or dividing. So I can't really think of a way to get from 12 to 18 easily without a calculator directly. So what I'm going to do is I'm going to go to 6 first. I'm going to divide the 12 by 2, so halve it, and then I'm going to times the 6 by 3. And that will get me to 18. Now, some of you might think, well, why can't we just add 6? Proportion doesn't work with adding or subtracting. You've got to times or divide to keep everything into proportion. So what I'm going to do with each of these ingredients is I'm going to halve them to find out what the amounts for 6 biscuits are. And then I'm going to times them by 3 to find out the amounts for 18. So half the 84 would be 42. half the 60 would be 30, half the 24 would be 12, half the 2 would be 1. And now, because we've got 12 biscuits here, and we've halved them to make 6, a different way of doing this is just adding them together. 12 plus 6 is 18. So instead of timesing the 42 by 3, I could just add it to the 84. So I could just do 84 plus 42, which would be 126. Again, 60 plus the 30, which is 90. 24 plus the 12, which is 36, and 2 plus the 1, which is 3. So the answers are 126, 90, 36, and 3. Okay, second part of the question says that we've got enough of every other ingredient, but only 1 kilogram of flour. Now, first thing to note here is that 1 kilogram is 1,000 grams. So that's really important to know for this. And we need 84 grams of, and I'm going to do my working up here, but normally in your exam, make sure you do it underneath the question. So we know that 84 grams gives us enough for 12 biscuits. So I want to work out how much 1 biscuit would be. So I'm going to divide both of those by 12 so that I can work out exactly how many biscuits I can make. So it's 84 and then divide it by 12, which you can do any method you want. The answer will be 7 grams. So 1 biscuit's going to be 7 grams. And now we've got 1,000 grams. So what we want to do now is we want to work out how many 7s there are in 1,000. So we need to do 1,000 divided by 7. And this isn't the only way of doing this. Now, to do 1,000 divided by 7, what you could do is just keep going through the 7 times table. You might start off with 7 times 100, which is 700, and keep going there. Or you might use the bus stop method. And there's loads of different ways of doing this question. So I'm going to use the bus stop method. 7s into 1 don't go, so that 1 carries on. 7s into 10 go once, and then we carry the 3. 7s into 30, well, 5 times 7 is 35, and 4 times 7 is 28, so it's going to be 4 with 2 carried on. 7s into 20, well, 7 times 3 is 21, 7 times 2 is 14, so it's going to be 2. Now, we could carry on and push on the 6 remaining, but actually it just shows us that we've got 142 whole biscuits and then some biscuits left over at the end. So we're only interested in how many biscuits he can actually make, which would be 142, but he might have like some flour left over, but it wouldn't make a biscuit. So the answer is 142. So we're asked to find the amount of females who went on the log flume from a sample of 40, even though the amounts are out of 79. Now this is called stratified sampling, and it means that we've got a sample, which means a part of the population. Our population is 79, and we're not going to ask everyone because that would take too long or cost too much depending on the circumstance. So we're only going to ask 40, but we want to make sure that we ask the people in the same proportions of male and female and the same proportions of who went on what ride. So we're looking at this one, which is the 11, because it says female who went on the log flume, and 11 people did. Now it's 11 people out of the 79, but we want a sample of 40. We're not looking to ask all 79, so we're not looking to ask all 11 of those people. So our sample as a fraction of the whole is 40 over 79. That's the fraction that we want of each of the 6 groups of people. The male who went on Big Dipper, the male who went on the log flume, etc., and the females who went on those rides. So the first thing to do on a stratified sample is find out the fraction of the amounts of people that you need. And we want that fraction of 11. So just times it by the amount that we're interested in. So I'll do that on my calculator now. 40 over 79 times 11 equals 5.5692 blah blah blah. Now unfortunately, fortunately, you can't carve up a person, so there's no point of having 5.56 as an answer. You need to make sure that you have an integer as an answer if you're talking about amounts of people or amounts of things. So if you have a question just like this, where it's just talking about one of them, you can normally just safely round it. There are some types of question where you need to work out whether it works, whether when you add up all 6 options, it does add up to 40. Now sometimes it will add up to 39 or 41, and you've got to see the one that was closest to rounding the other way and round that the other way. For this type of question, because we're only looking at one and it's quite a simple question, I wouldn't go into that much detail. Okay, to convert from standard form, you just write the number down, and this here, the power, will tell you where to go. So if the power is positive, then you go to the right. If it's negative, then you jump to the left. Now since it's negative, we're going to jump to the left, and it's -6, so we're going to jump 6 spaces. So 1, 2, 3, 4, 5, and 6. So the decimal point will now be here, and you fill in all of the jumps with zeros. So one of the jumps is used by the 8, but all the other ones we fill in with zeros. And whenever you've got just a decimal point, you need to have something before it, so we put a 0 before it. So the answer will be 0.00000084. That would be the answer. So let's just count. There's 5 zeros and 5 zeros. Okay, to convert to standard form, you write out the number and you try and put a decimal place in to make the number between 1 and 10, but not including 10. So if I put it in here, that would be 72, so that would not be right. So I need to put it in here. Then you count how many times you had to move the decimal point to get it there. So the decimal point started at the end of the number, and we had to move it 1, 2, 3, 4, 5, 6. Okay, so the rule is that the number has to be between 1 and 10, which this one is. Now, if you had a big number, then the power of 10 will be positive. Now here we did have a big number, so it's going to be +6. On the previous one, we had a small number, 0.00084. I don't know if I said the amount of noughts that were there, and you can see that the power in the question was negative. So negative power of 10 is really small number, positive power of 10, really big number. This does turn up on the calculator paper as well. So if it does, you can actually just type in question A into your calculator and just write down the number it gives you. Now some calculators are smart and do things in standard form, so you might need to do it this method anyway. Okay, I'm just going to write this out to make it a bit bigger. Now we're asked to make A the subject, which means we want A equals. So I'm going to put my lines down. Now the first thing I need to do is get rid of that square root, because if you look, the right hand side is all trapped in that square root. So what I'm going to do is square both sides. So we've got t squared equals, and when I square the square root, it just gets rid of the square root. Okay, next I need to get rid of that 3, so I'm going to take away 3 from both sides. So we've got t squared minus 3 equals 10a. Then I'm going to get rid of that 10. Now that's a times 10 there, so I need to divide both sides by 10. Now I could divide the t squared by 10 and the 3 by 10, or I can just write it as a fraction, which is a lot easier. So just put the whole thing over 10. So therefore a equals t squared minus 3 over 10. Now it's really important that if the letters are capitals, we keep them as capitals. If they're lowercase, we keep them as lowercase. It does matter what case the letters are, so if it's uppercase or lowercase. In this question we're asked to compare two banks, and normally when I'm asked to compare something I just put a line down the middle of the working out and I put one of them on the left hand side and one of them on the right hand side, and as long as it's identifiable which one is on the left and which one's on the right, you don't need to necessarily put the whole name down, but you can do. So I'm going to start with a super bank. It says we have 2.3% for the first year and 1.8% for all other years, and we're doing this for 2 years at £300. So first of all I want to work out what the multiplier is. Since this is the calculator paper, we use the multiplier method. So we start off with 100% always, and compound interest means we're gaining money, so we're going to go up by 2.3%, so that means we'll have 102.3%. So as a multiplier, what we do is we just divide that percentage by 100 to get it as a decimal into what we call a multiplier, 1.023. So if I times 300 by that, that will tell me what we have after year 1. So let's do that and calculate 300 times 1.023. And you might need to press S to D. And that is £306.90. Okay, so that's year 1, and we might as well just write year 1 somewhere. Okay, so year 2, we've got that £306.90. And we need to work out the multiplier for 1.8. So I could go through the same method as before, but actually when you start using multipliers you realise how to just go straight there. So it's going to be 1.018, but you could do 100 plus 1.8 is 101.8 and then divide that by 100. And what's that going to be? So that equals came out a bit wrong. So what's that going to be? So 306 and times 1.018, and that says it's £312, and I'm going to round this 42. I'm going to round it to the nearest penny. Okay, so that is Superbank. That's how much we'd get. Now the Great Bank's a bit easier because it's just going to stay at 2.2. So let's work out as a multiplier. 100% plus 2.2% equals 102.2%, and then as a multiplier that is 1.022 by dividing it by 100. So we're going to times that £300 by 1.022, so 300 times 1.022, and I get £306.60. Then I'm going to times that again by 1.022, so times 1.022, and this time I get 313.34. Ooh, actually that would be 5 if I round it to the nearest penny. Okay, so it says which account will give her the most money. Well, looking at that, it's going to be the Superbank. And when you're writing down an answer, make sure you write down the full name. Oh, it's not going to be Superbank, it's going to be the Great Bank. Look at that. So Great Bank Inc. And then it says by how much. So I'm going to get that by how much. Let's show the examiner what I'm doing. So I'm going to do 313.35, take away 312.42. So 313.35, take away 312.42. And I get the answer of 93p. So £0.93. Now, if you hadn't have rounded both of those, you might get a slightly different answer. And actually, technically, you shouldn't have rounded them until you got the answer. But on a question like this, where you're rounding it to the actual money she would get, they wouldn't pay her half a penny, then either answer would be correct. And in this bit here, you could have done all of this just as one bit, you could just written 300 times 1.022 times 1.022 or times 1.022 squared. That would be absolutely fine because you'll get the same answer. Okay, so for this question we need to work out the length of the arc, which is around here, and then we need to work out what this and this are. So we're going to do arc first. I'm going to show the examiner that I'm doing the arc first. Now the distance of the arc is the total circumference of the circle times by the fraction of the circle we've got. So you want to work out what the fraction is of the circle and times it by the circumference of the circle. So to work out the fraction of the circle we've got, well, we've got 146 degrees and there are 360 degrees in total in a circle. The formula for the circumference of the total circle is pi d, or 2 pi r. Well, here we've got a radius because it's halfway across the circle. If you imagine the whole circle looks something like that, then the 37 is the radius. So we need to first of all double the radius to get the diameter, and so we're going to do pi times 74, which is twice 37. Okay, so we type that all into our calculator, so I press the fraction button, 146 over 360 times pi times 74. And it gives me in terms of pi. I don't need it in terms of pi, I just need it as a decimal. So 94.2826 blah blah blah. Now that's for the arc length, but we also want to know what this distance here is. Well, we've already got that one. And what this distance here is. Well, they are both radiuses, or radii we call it. So that's also going to be 37 meters. So to work out the perimeter, I'm just going to get that 94.2826 blah blah blah, and I'm going to keep it in my calculator, and I'm going to add 37 and add another lot of 37. So add 37, add 37, and that gives me 168.2826 blah blah blah. Once it's 2 decimal places, so line goes down here and we've got 168.28. Now just be careful that you add on the extra bits. When it asks you for a perimeter, just make sure you've gone the total distance around the shape. Put a dot and just draw with your finger around the shape to make sure you've got all the distances. Okay, so whenever we're asked to find an inequality or draw an inequality onto a graph, always draw the line but without the inequality in it. So instead of x is greater than or equal to 5, always draw the line x equals 5. If it can be equal to it, it's a solid line. If it can't be equal to it, it's a dashed line. Okay, so it's x equals 5, and I'm going to draw a solid line. So where does x equal 5? Well, x equals 5 here, and here, and here. And in fact, anywhere along that line, it's just a vertical line up, and that's the line x equals 5. And it's really important to remember which way around it is. Whenever you have x equals something, it's always a line from top to bottom. When you have y equals something, it's always a line from left to right. Okay, that's the line x equals 5. But it asks us to mark the region in the inequality with an R, so it's either going to be to the left or the right of this line. Well, it says that x can be anything that's greater than or equal to 5. So x could be 5, 6, 7, 8 on this graph, okay, because obviously it only goes up to 8. So anywhere this side of the line is absolutely fine, so I'm going to mark my R there. And actually sometimes the exams ask you to shade it in, so I just shade in that right hand side of the graph. Sometimes you shade in what you don't want, and if I was shading in what I didn't want, obviously it would be on the left hand side of that graph. Right, when working with bounds, the easiest way of answering the question or thinking it through is just to do a quick number line, put the number that's been rounded in the middle, and try and figure out what the next one down is. Well, it's to the nearest 5, so the next one down is going to be 80. Now we could do the next one up, but it's asking for the lower bound, so we're only interested in the lowest possible values. Now, next thing is to work out what the cutoff point was. Why was it rounded to 85 and not 80? At what point did it need to be higher then? Well, the point at which it needs to be higher is halfway between the two, which is 82.5. So that's our lower bound for the 85. Then just repeat the process for the 160. So we've got 160 in the middle. And the next one down would have been 155. And then when we draw the line, well, it's going to be 157.5. Now, what many students would do is just look at the number. Well, the area is going to be 85 times 160, and that's what the area is going to be. But we know that the 85 could have been 82.5, and the 160 could have been 157.5. And that would give the lowest possible area. So if I get my calculator out, 82.5 times 157.5, and that gives me 12993.75. And it doesn't ask me to round it, so I'm just going to write down the exact number. Now be careful, with areas we're timesing them, so we want them both to be small, but if you were to divide them, sometimes you actually want the upper bound of one of the values, but for area you want them both to be as small as possible to give us the lower bound for the area. To solve a quadratic, first thing you need to do is get it equal to 0. So I'm just going to write it out first of all. And then I'm going to draw my lines down so I can show the examiner what I'm doing. So the first thing I'm going to do is take away 6x both sides. So it's going to be x squared plus 7x minus 14 equals minus 10. And then I'm going to get rid of that minus 10, so I'm going to add 10 to both sides. So it's going to be x squared plus 7x minus 4 equals 0. Now the first thing I do is look at it and go, can I factorize it? Well, given the fact that it wants an answer correct to 2 decimal places, that's a bit of a hint that you're not going to be able to factorize it. Because when you factorize it, you'll normally end up with a much nicer number. And if the coefficient of x squared is 1, you'll end up with an integer. So we're going to have to use the quadratic formula, and there are other methods, but the most common one is the quadratic formula, so that's what I'm going to do. So the quadratic formula says x equals minus b plus minus the square root of b squared minus 4ac over 2a. Now you might say to yourself, well, what is a, b and c? Well, hopefully you don't, because if you're doing this question, I would assume you do know what the a, b and c are. But for those of you who don't, a is the number before the x squared, b is the number before the x, and c is the leftover number. Now, the number before the x squared is 1, because there's no number there, so it's 1. The number before the x is 7, and the number on its own is minus 4, and that's really important that you understand that that's not 4, that's minus 4. So when I substitute it in, so b was 7, so it's minus 7 plus minus square root of b squared, well that's going to be 7 squared, so I know that's going to be 49, so I might as well write 49. Now it's minus 4 times a times c. Now a is just 1, so we can ignore that. Minus 4 times c, which is minus 4. Well, minus 4 times minus 4 is going to be a positive 16 over 2 times 1, which is just 2. Now you could, at this very early point, just type this into the calculator and that would be absolutely fine. Just make sure you put brackets around this and put any negatives in using the special minus button, which on the Casio calculators is 2 spaces above the 7. Okay, let's keep going there. So I might as well just type this in now. well, I can finish it off. I can do the 49 plus 16 without a calculator. So let's keep going. Let's do it without a calculator for a little bit. So that's going to be square root of 65 over 2. Okay, this plus minus thing here just means that there's going to be a plus answer and a minus answer. So we split it up into 2 at this point. We have x equals minus 7 plus root 65 over 2. And we have x equals minus 7 minus root 65 over 2. And what you can do is just type that into your calculator, press the fraction button, then minus 7 plus root 65 over 2, and then you press equals, and that gives an answer for us. So I'm going to put that straight in, I think. No, I'm going to show the examiner, I know. I'm going to show the examiner. So 0.531128 blah blah blah. And then what you can do is on the Casio calculators you can just use the cursor button, which is the big blue round one, to move across, go to that plus, delete it and change it for a minus. It saves you having to write the whole thing out again. And then let's have a look. And if yours comes up as a fraction or something, just press the S to D button. It converts it. That's minus 7.5531128 blah blah blah. Okay, it says to round it to 2 decimal places, does it? Yeah. So we want 0.53. So 0.53. What else? Minus 7.53. So minus 7.53. There's our answers. Okay, so this question is involving a probability tree diagram. And if we read the question, it says that the counter's not put back in the bag. Therefore, we know it's going to be conditional. Now, conditional means that the probability of the second event, so taking the second counter, depends on what you did the first time round. Okay, the way probability trees work is you start on the left-hand side, and you have an option. You can either go up if you pick blue, or down if you pick red. Now, because you have to pick one of the options, the two options have to add up to 1. So if blue is 3 over 7, the bottom one must be 4 over 7. Has to be, because then it adds up to 7 over 7, which is 1. Now, if we picked a blue on our first counter, the probability of us picking a blue again is 2 over 6. So therefore, the probability of us picking a red will be 4 over 6. Okay, now let's see where those numbers have come from. It says in the question that there are 3 blue counters and 4 red. Therefore, the first probability of a blue being 3 over 7 is because there's 3 blue counters and there's 7 altogether. The second probability, so if I picked a blue on the first counter, went down, well, if I picked a blue again, to 2 over 6. That's because there's 2 blue counters and only 6 left altogether. So we need to know that to be able to fill out the bottom one. So if I picked a red on the first time round, what's the probability I'll pick a blue? Well, let's have a think. There are still 3 blue counters in there, but there are only 6 left altogether left in there because we've picked a red. So the probability of us picking a red, well, there were 4 before we picked one, but we've picked a red, so therefore there are 3 reds left and 6 left altogether. Now, I'm deliberately not cancelling these down. I could cancel it down to a third, 2/3, half, half, but I'm just going to leave it as it is for now, just to make things simpler. Okay, question B says, work out the probability that the 2 counters picked are different colours. So let's follow our routes along. I'm going to go up and then up, so blue and then blue, blue and then red, red and then blue, and you're always starting from this point here, and then red and then red. Now let's have a look. Blue and blue are not different colours, so we're not interested in that. Red and red are not different colours, but the middle two are. So what you do with probability trees is you start here and you collect all the fractions that you went past on your journey to the end. So we went past 3 over 7, and 4 over 6. Now the word and there is really important because and in probability means times, and you're always going to multiply them when you're going across a tree diagram. So I'm going to times the tops and times the bottoms. Again, I'm not going to bother cancelling down at this point. Okay, so the other option is I pick a red first and then a blue. So that is 4 over 7 and mean times 3 over 6. That's going to be 12 over 42. And normally these two will be the same. Okay, so just be prepared for that. Not always though. Okay, so we had 12 over 42 for the first option and 12 over 42 for the second option, but we can't pick both options, and this is the problem. We've got two probabilities, two answers. Well, we can't possibly have that. The word or comes into effect here. We either pick a blue and then a red, or a red and a blue, and the word or in probability means add. So all we need to do to finish this question is add the two options we had. So when you're going down here and you're collecting all the fractions you got, you just add them together. So we're going to add the tops together, which is 24 over 42. So it's half top and bottom, and let's cancel it down now. 12 over 21, and I think I can divide them both by 3, so it'd be 4 over 7. So my answer is 4 over 7. There are a few different ways of answering this question. I'm going to show you what I feel is the easiest technique, but if you've got a different technique you get the same answer, then stick with it. This question will all be about multipliers and understanding how to use them, but the difficulty in this question is we're finding out how long it will take to get to a certain point, which is a big twist in this question, and we're not given a quantity. Now, whenever you're not given a quantity, one method of being able to do it is by putting in your own quantity, and the easiest quantity to put in is the number 100. So I'm going to pretend that the population of the town at the start is 100. Now this question, as I said, is all about multipliers, so we need to figure out what a decrease of 6.5% as a multiplier is. And to do multiplier, you start off with 100%, you do whatever the question's saying, so this time we're decreasing by 6.5%, and this will be on the calculator paper, so you might as well use your calculator to do 100 take away 6.5, and hopefully the answer is 93.5%. And to convert it into a multiplier, you just divide by 100. You're just converting it to a decimal, but the paper will call it a multiplier. That would be 0.935. So whenever I times something by 0.935, I've decreased it by 6.5%. Okay, so we've got 100. And what I want to do is figure out how many times I need to multiply it by 0.935. Okay, so there's a power here which we don't know yet, to get the answer that is less than 47% of it. Well, the reason I pick 100 as my quantity I've made up is because 100 is nice and easy, because 47% of 100 is 47. So we need it to be less than 47. Now what I do on my calculator is I type in 100 and I times by 0.935 and I get the answer of 93.5. Now what I'm going to do now, and that's one time, what I'm going to do now is press answer times 0.935, and what that will do is allow me to go through this same calculation as many times as I want by just pressing the equals button. So I'm going to press the equals button once and I get the answer of 87.42. So I've done twice in total so far, and I can leave a little tally mark here. I press it again and I get 81.7. Again 76.4. Again 71.4. Again 66.8. Again 62.4, so I'm getting closer. Again 58.4, again 54.6, again 51, I'm getting close. Again 47.7, so I'm getting very close, but I'm not quite there yet. and I press it one more time and I get 44.6. So in total I've done it 12 times. Now I'll always want to check that because my counting is not necessarily the best when under pressure. So what I'm going to do is I'm just going to do 100 times 0.935 to the power of 12 to check that I've got this right. So 100 times 0.935 to the power of 12, and I get 44.64. And I'm just going to check that that was the first time it went under. So I'm going to do to the power of 11, and what I can do is just scroll through my working out on the calculator and change the 12 to 11 and press equal, and that's 47.744, blah blah blah. Okay, each of these are rounded. Okay, so it's going to take 12 years because 11 years gets us close but not quite over the line. It's the 12th year that it dips below 47%. Now, as I said, there are different methods. You don't need to include the 100 as a made-up value. What you can do is just look at the multiplier and wait until the multiplier is 0.47 or below, below 0.47. And the multiplier would go down to 0.4464, blah, 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 blah. That's absolutely fine method. And there are other ways of doing divisions, which I'm not going to go into because you don't need to go that far. Because when you hit A level, there's a much, much better way of doing it, but we don't go through it at GCSE. If you wanted to look into it, it's to do with logarithms, but we won't go into that. Okay, so we've got an exponential graph. The reason we know that is because it's to the power of x, and we're given 2 points on it. So the way I'd start this question is to just look at this point here and substitute in the values. So we've got 15 equals ka, right, to the power of 1, which is just a. Then underneath it, I'm going to write this one here. So it's 135 equals ka to the power of 3. Now I'm going to think about what I do to the right hand side here to get from ka to ka cubed. Well, I'm going to times it by a squared. So I think, well, what do I do to this side? So I get my calculator and I do 135 divided by 15, which is 9. So I'm going to times it by 9. Therefore, a squared must be equal to 9 because we're timesing the left hand side by 9 and we're timesing the right hand side by a squared. So we then square root that. Now this is where it gets interesting. You actually get a positive and a negative 3, but the reason I know it's positive 3 is because if it was a negative, the actual graph would look like this. So if it's a normal exponential graph, which this is, because this passes through 1 here, then it's going to be a positive power. If it's a negative power, it means it's a fraction, and therefore it will never quite get to the y-axis. But you don't need to worry about that. If this was asked, it's normally going to be a positive, but having said that, it might not be. So anyway, I then use that a into the first equation, so 15 equals k times a, well that's going to be 3k, and then divide both sides by 3 and you get k equals 5. So k equals 5 and a equals 3, and I just need to check that. So let's do the second equation, so 5 times 3 cubed. So 5 times 3 cubed is 135, so I know I've got it right. Okay, so for this question, this is all about linear, area and volume scale factor. So with this question, from B to A, we can work out the linear scale factor. So what do I times 5 by to get to 10? So the linear scale factor is going to be big divided by small, which is 2. Now the area scale factor is always the square of the linear scale factor. So we square it and it's going to be 4. The volume scale factor is always the cube of the linear scale factor. So we cube the linear scale factor and it's 8. So with this first question, it says cuboid B has the volume of 80. So if B has 80, the volume of A is going to be 80 times the volume scale factor, which is 8. So that's going to be 64 with a 0, so 640. And it's that simple. This one here, it says cuboid A has a total surface area of 440. So work out the surface area for B. Now this is surface area this time. So it's going to be 440. Now because we're going from bigger to smaller, we're going to divide by the scale factor. And it's the area scale factor we need, which is going to be the 4. So we do 440 divided by 4, which is hopefully 110. And it's that simple. So you just got to remember that if you have a linear scale factor, you square it to find the area scale factor, and you cube it to find the volume scale factor.
There are a few different methods to answer this question, but I prefer the method where we just replace f of x with y because it becomes a lot easier. So I'm just going to write out the same equation. Now, when you want to find the inverse, which this is, of the function, all you do is swap the y and the x around. So we're going to have x equals 4y minus 10 over 7. And then all we need to do is get it so we've got y equals. So the first thing I'm going to do is times both sides by 7 to get rid of the fraction. So we've got 7x equals 4y minus 10. Then I'm going to add 10 both sides. So we've got 7x plus 10 equals 4y. And then I'm going to divide both sides by 4. So I've got 7x plus 10, all of that over 4, equals y. Now, it's not y really, it's f, inverse of function, x equals 7x plus 10 over 4. And the 7x and the plus 10 can be either way around. So 7x plus 10 over 4.
To simplify a fraction, you need to divide top and bottom by something. So if I just try and divide top and bottom by something now, I need to find something that all 6 terms have in common. Well, there is nothing that all those terms have in common. So the way of starting this is to factorize the top and bottom, so put them into brackets, and then something will turn up. So let's factorize the top. So I know it's going to be x at the start. I need 2 numbers that add together to make 12 times together to make 35. Well, that's going to be 7 and 5. Then I need to factorize the bottom. Now, a little bit of a cheat here. I know one of them will be the same. So either one of them is going to be x plus 7 or one of them is going to be x plus 5. So I need 2 numbers to add together to make the 10x times together to make 21. Well, I know that 5 doesn't go into 21, but I know 7 does. So x plus 7 and x plus, well, to make the 21 and the 10 needs to be 3. And all you need to do is divide top and bottom by, let's do it top and bottom. Get rid of that. Ugh. So all I need to do is divide top and bottom by x plus 5, x plus 7 even. And what that does is just gets rid of that and gets rid of that. The fraction stayed the same, but now it's x plus 5 over x plus 3.
There are quite a few different approaches for this question. One thing we can do is try and find length AD by using the cosine rule. And the other approach which I'm going to use is I'm going to work out this angle here using the sine rule, and then work out this angle here taking away from 180 degrees. Then when I've done that, then I can use the trigonometric area formula. So I'm going to work out the angle I marked first. So that is angle ADC. That's what I want to work out first. Now to do that, I'm going to call that, let's call it X. So it's a bit easier to write. So I'm going to use the sine rule, and that says that sine X over, so this is sine X, this is X here, so it's going to be over 8 equals sine 110 over 12. And the reason it has to be that way around is obviously sine matches up opposite angles and lengths, so it's going to be those two and those two. So first thing I'm going to do is just times both sides by 8. So it's going to be sine X equals 8 sine 110 over 12. And then what I'm going to do is inverse sine both sides. Scroll down a bit more. So X is going to be the inverse sine of 8 sine 110 over 12. So let's get my calculator. So inverse sine, fraction button, 8 sine 110, close the brackets, over 12, and then come out of the fraction, close the brackets. So that tells me that X is 38.789 blah blah blah. Now I want to keep the accuracy if I can, so I'm going to keep that in my calculator, and then what I'm going to do is add that to the 110 to work out what this angle here is, and I'm going to call that Y. So what is this? ACD. So I'm going to tell the examiner that ACD I'm going to call as Y, just to make it a bit easier. So Y equals 180 take away 38.789 blah 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 plus 110. So I'm going to add 110 to that, then I'm going to type in 180 take away the answer. So that tells me that Y is 31.2104 blah blah blah. Okay, so I've worked out what Y is, which is good, because when you have a length, then an angle, then a length all together, then you can use the trigonometric area formula. And the formula is dead easy. It just says that area equals half AB sine big C. So we know the problem is actually we've got two triangles. We've got a triangle here, and then we've got an identical triangle here, and it is identical because the diagonal of a parallelogram cuts it in half exactly. So what we also need to do is then times this by 2. Now if we notice that the half and the times 2 will cancel, so it's just going to equal AB sine C. Now I've kept that number in my calculator, so I can use it. It was A and B. A and B are going to be 8 and 12. So it's going to be 8 times 12 times sine 31.2104 blah blah blah. So let's quickly use the calculator before it switches off. So I'm going to press sine answer, close bracket, times 12 times 8. And it says the answer is 49.7455 blah blah blah. Let's have a look and see the accuracy that I need. 1 decimal place. So let's have a look. That's going to be 49.7. Now, if you didn't keep the numbers in your calculator and you rounded them, make sure you round them to 4 or 5 decimal places. So I would probably round it at least to 3 decimal places, but you normally want to go a little bit further. you might find that if you rounded it, you might get a slightly different answer to mine. Now, that's why you must show you're working out, because if you got, say, 50 rounded to the nearest decimal place, or 49.8 or something, then if you can show you're working out, if you can show that you've done all of the steps and the reason why you got slightly off was because you rounded some of your working out, you might get full marks, but you would get at least all but 1 mark for the question.
This is a question about iteration, and question A is a little bit harder maybe than the exam will go, where it asks you to come up with your own iteration formula. So, in order to do this, it says that fx equals 0 for this formula. So the first step is just to get it equal to 0. Now the question's given you a hint because it says that it involves a cube root. So we know that we're going to have x cubed equals something, and then we're going to cube root both sides. So I'm going to just put my lines down. And we're going to add x and add 5 both sides. And we're just going to cube root both sides. So our iteration formula is going to be the cube root of x plus 5. Now, with the iteration formula, it's a beautifully simple idea that this formula will, as long as we just keep ploughing in what we've found for the answer before, it will get us closer and closer to the real root. Now, sometimes the roots are infinite, so we could be sitting there all day and it will get a closer and closer and closer answer. This is why the question will say, 3 decimal places or 4 decimal places. So that will tell us when to stop. So it always will give you a first one, okay, the x0, the first one to try. And all you're going to be doing is putting that 1 into this formula here. Okay, so let's try it. So cube root of 1 plus 5, and that gets me 1.81712 blah blah blah. Okay, now I need to keep that answer, so what I'm going to do is I'm going to press the cube root button, then I'm going to click inside the root, I'm going to click answer plus 5. And the calculator will remember the answer to the one we had before. Now, if you try and round them, you will get very, very different answers. And it might take you a little bit longer, or you might make a mistake. So you let the calculator do all the remembering for you. Then I press equals, and I get 1.89612, blah, blah, blah. So I'm going to do the same again. So I'm going to do the cube root button, answer plus 5, and we've got 1.9034 blah blah blah, cube root button, answer plus 5, and we've got 1.9040 blah blah blah. Now we're looking for 3 decimal places, so the numbers we're looking for being the same are these ones here. Now, we've almost got them the same, but we're not quite there, so we need to do another one. So cube root, answer plus 5, and we've got 1.9041, blah blah blah. Now, even if you were to carry on going, the first digits, the digits I've circled with I've put a red square around, are going to remain the same. So as soon as you get 2 that are the same to 3 decimal places, that is your answer. So my answer is going to be 1.904. Now, obviously we haven't got it perfect, but if you carry on the iteration, you won't ever get anything different to 1.904. The only numbers that will change are beyond that. So that's why we can confidently stop now and say, yes, that's our answer.
First thing to notice with this question is that to find a distance of a velocity time graph, you've got to work out the area underneath the curve. Now at A level there are much easier ways of doing this, but we at GCSE have to do this using the trapezium rule. Now the trapezium rule goes as follows. You're going to carve that curve, or the underneath of that curve, up into trapeziums to try and estimate, and this is what it asks us to do, the area underneath it, therefore the distance. So it says it will always give you hints about what it wants you to do. So it gives us a hint saying that it wants it between 2 and 10, but it wants it in 4 equal intervals. So if I do 2 and 10, so we can get started. Now let's have a look and see how many squares there are in between them. There's 8. So if we want 4 equal intervals, we're probably going to go up in 2s. So let's try 2s and hopefully it will work nicely. Now we haven't created trapeziums yet, so let's create trapeziums now. So we're going to create trapeziums for these 4. There we go. Okay, let's try and get the heights of these trapeziums, and I normally draw it onto the graph itself. It's a little bit easier to get my head around. So that's, I think that's 11. I think that's 6. I think the height of this one is probably, because I've drawn it badly, I think it's 3. Height of this one is 2, and the height of this one I think is 3. And the width of them is 2, so all of them is 2. Okay, so we need to remember how to work out the area of a trapezium. It's half a plus b h. Now this is quite misleading because h actually using the trapezium rule is the width of the trapezium. It's because the trapeziums are kind of on their side. So h is always going to be 2 for these. So what I would do is just number the trapeziums that I'm doing. So I'm going to do number 1. Now number 1 is going to be half 11 plus 6, because A and B are the ones on the left and right of the trapezium, times 2. And I can use my calculator for this, so it's going to be 17 divided by 2 times 2. I don't know why I'm dividing by 2 and timesing by 2. It's just going to be 17, because the half and the 2 will cancel out. So the second one is going to be half, and this time it's 6 plus 3 times 2. Well, we know the half and the 2 will cancel out, so that's just going to be 9. The third one, the third trapezium, and if you want to, you can actually just number them on the actual thing itself to show the examiner, yep, this is the one I'm trying to work out. So that's going to be half, and what is it this time? 3 plus 2 times 2, which is just going to be 5. Let's just scroll it down a little bit. So the fourth one is going to be half 2 plus 3 times 2, which is also going to be 5. So to work out the total distance, 7 plus 9 plus 5 plus 5, 17, sorry. So 17 plus 9 plus 5 plus 5. I don't know why I'm using a calculator for this as well, but it's here, so we might as well use it. So it's going to be 36. Now commonly with this question you're also asked whether it's an overestimate or underestimate. If you have a look at the trapezium, this bit here and this bit here, we've counted that as area, and actually there's little thin strips down here. We've counted as area that actually isn't area. So this one will be an overestimate. If your trapezium goes the other way and it doesn't quite hit the curve, then it's going to be an underestimate. To be able to answer questions like this, you've got to be able to sort of think in 3D. So try and imagine that this box is sitting in front of you. You're asked to find the angle GEC. So if we go from G to E to C, then we're being asked to find this angle here. Well, we know to find an angle, we're probably going to be using trigonometry. And at the moment, we only have one length. We have that 11 centimeters at the end, which will be the opposite. So if I mark that, that's the opposite when we use trigonometry. Now, the hypotenuse is not something we can easily find. So the hypotenuse here, well, we can't really easily find that, so that's probably not what one that we're going to be looking for. But the adjacent at the bottom, if you have a look at the bottom, the adjacent here could be quite easy to find, because if you have a look at the right angled triangle here, we have two of the lengths. We've got the 5 and the 6, and we're looking for the third. And because it's a cuboid, we know that that's a right angle there. So the first thing I would do to start this question off is just copy down the triangle that we've got at the bottom. So it's 6 centimeters and 5 centimeters, and all of them in centimeters, so I don't need to put the units just yet. Okay, so to do that we use Pythagoras, so we're going to square them, add them, and then square root it, and we call this EG. There's line EG, not for example. So, I mean, we can use our calculator for this. Root 25 plus 36, and that's root 61, and we can leave it as root 61 because we don't want to have to round it at this point. Okay, so the next thing to draw is the right angle triangle that the purple one that we've got on the diagram. So let's start drawing that. Oops. Okay, so we've got A at the bottom, which we now know is root 61. Let's scroll down a bit. And the height is 11, and we're looking for this angle here. And we can call this angle X, why not? Okay, so to do this question, we need to label the sides first. So that's the opposite and that's the adjacent. We need to just quickly write SOHCAHTOA so that we can check which one it's going to be. And it's TOA that has the opposite and adjacent. And so we're going to write down tan, and we called it X, equals opposite over adjacent. Tan X equals, well, the opposite's 11 and the adjacent is root 61. And we're going to inverse tan both sides. Just standard trigonometry. So inverse tan and fraction 11 over root 61, and just close the bracket. There we go. And it says that X is 54.62438 blah blah blah. It says it wants its 2 decimal places. So the answer I'm going to write is 54.62.
Okay, I hope you enjoyed that video. Like I said, you can do the questions online. On the online paper, all the numbers constantly change, so you're not just remembering answers, you're remembering techniques. We also have the new Revisionator online, which is a really, really good tool to just do random questions. We also have mock exams, demon questions for the harder questions on the GCSE course, mini mocks, and there's all sorts of other things on the website. We also have the remaining topics on our website, which you can just go through all the exam questions we have for the remaining topics. If you like this video, please click like, and if you want to see more from us, click subscribe. Thank you very much.